Welcome to the shop. I'm continuing NQALHA production run 4, making 750 parts. That's a lot of parts. Better get busy. The part that I'm making today is done with the same standard scheme that I use on many of my parts. The blank is first put in the right vise, work offset 1, G54, 0 at the left rear corner, Z0 at the top of the part. First operation, then over to the tooling plate on the left vise, work offset 3, 0 at the top of the tooling plate, 0 at the left rear corner. I mill, or actually sand, a little chamfer on the tooling plate so that I can remember which way to insert it, even though it's pretty obvious by looking at the shape of the part. So I've already done all of the setup. I set the 0 with the Heimer indicator and set the Z0 with the Tormach automated tool setter, or electronic tool setter. It's not automated, it's just it's a measuring device. I showed the full detail of setting up the machine in previous videos, and I'm not going to go over it again because it's pretty repetitive. The Heimer indicator is an excellent tool that measures X, Y, and Z, and I only use it in X and Y. I've never used it for Z, but it does have that capability. So this is going to be a kind of an interesting little part. The first and second operations are very simple and go very quick, but the third and fourth operations are drilled and counterbored at fairly odd angles using a fairly odd custom-made fixture that holds the pieces in place. And so let's get going. Got the program loaded up. This is a known trusted toolpath that I've run many times, but as always, going to be very careful and slow. I think I have the tool changer back in adjustment, although it's been causing me a lot of problems lately. The Tormach automated tool changer on the older generation, which I have the PCNC 1100. I don't have the more modern MX. And the old generation tool changer is a pretty borderline design, and I've been having a lot of problems with it recently, but let's see how it works today. So, like always, single block. Verify that the tool stops an inch above the surface, roughly an inch, somewhere in the neighborhood of an inch. And verify that, yep, looks like it's roughly in the right place. There's a display on the Path Pilot screen that shows what kind of a contour I'm going to be cutting, and it looks reasonable. So I'm ramping in to avoid plunging, to try to keep the cutter a little bit cleaner, using the Lakeshore Carbide aluminum shredder, a 3-flute roughing cutter with serrated flutes that produces very fine chips, cutting in 3 passes through 3/8 6061 aluminum. The cutter comes out not quite as clean as I would like it, but I haven't yet figured out how to make it come out a whole lot cleaner, so it is what it is. Okay, 1 inch above, which I call the pre-feed height, feed height correct, doing the finish cut with the Lakeshore Carbide 3-flute, straight flute zirconium nitride coated aluminum cutter, This hole is somewhat critical. It's not like ultra critical, but it's somewhat critical because it's where one of the magnets mounts, and so it has to be kind of close to the desired size. I'm going to check it here with this fixture plug that I'm going to use for the next operation. The fixture plug fits in nice and snug, maybe a little snugger than I'd like it actually. So once again, when I'm doing the combo toolpath where I load up a first and second operation part, I prepare for this by doing the first operation twice. Make sure that the tool changer isn't going to hurt me. Yep. Oh, here's another Tormach tip and trick that in the process of while the tool changer is changing tools, it really isn't very stable. And don't try to blow the chips off the end of the cutter during a tool change, or bad things will happen. So now I'm deburring this guy in preparation for the next operation. I've got a little hold down that I made with a kind of a little edge on it like that, and then it has an aluminum washer to avoid boogering up the surface with the socket screw, and this will hold the blank, or not the blank, the first operation part onto the tooling plate for the second operation. So looking pretty good. This operation produces a whole bunch of these little slugs, and I often thought, well, wonder if I could use those for something. Wonder if I could make something fun out of them, but haven't figured out anything to use them for yet. So at the moment, I'm just go in the bin. The second operation over here, I'm going to be cutting the profile, and have to kind of like eyeballically, let me get this over here. I've got quite a lot of tolerance on this thing, but as you can see, it's just held in place with a screw, and so I got to kind of like eyeballically and fingerifically line it up, which of course is close enough. So I'm going to load the combo tool path. Which is also a known trusted tool path, but since I haven't run it this morning, I'm going to be a little careful. Pre-feed correct, feed correct, ramping down. I've tried both ramping and pecking to get as an alternative to plunging the tool, to try to keep the chips off the tool. And ramping and pecking work a little better than plunging, but I still haven't come up with the magic tool path to completely keep the tool clean. Now, you know what? I bet, since both of these milling operations use the same two tools, if I do what I did a couple of videos ago and kind of intertwingle them, I can eliminate two tool changes. So I'm going to probably go in the CAD room and dick with it. So here comes second operation. Looks reasonable. Throw the old eyeball on it. Looks sane. Almost all of the tool paths in this production run are going to be tool paths that I've run before, unmodified, and I probably could just run them without being so careful, but it only takes a few extra seconds to be a little bit extra careful, and I sure do hate ruining parts and breaking cutters. And it's looking reasonable. And tool change, let's watch the tool change very carefully. Ah, memory is faulty. That does not use the same tool. That actually uses a 1/4 inch end mill because one of my inside radii, I need my inside radius to be a little on the small side because of clearance issues. And so the finish on that is not done with the 3/8. So maybe that toolpath optimization can only be done on the roughing cutter. Memory is faulty. "30 inches per minute, taking a 15 thousandths finish pass. And toolpath is now verified. Not sure it's worth taking the time to go into the CAD room and dick with it just to try to shave a few seconds off, but I don't know. I'll figure out something. I'm going to turn off the camera, go into production, get this first and second operation run complete, and then come back out and show you how the second and third, actually second, third, and fourth operation go. This part has a lot of stuff going on in it. Second and third and fourth operation on milling machines, and then kind of run the tap through with a hand drill for reasons I'll detail in the next segment, where the reason that I can't do a power tapping cycle on this guy. So I'll see you later. So after thinking about it for a few minutes, even though it probably in the grand scheme of things wasn't worth doing, it's still sometimes fun just to do it because, hey, why not? It's fun. I'm not in that big of a hurry. I've intertwingled the tool paths and modified and optimized to try to minimize the number of tool changes and minimize the number of rapids back and forth between work offsets. So now, here we go with the newly improved and optimized combo tool path. Tool change accomplished successfully. The unload position is more convenient when it's in work offset 3. So I start off the combo doing the roughing on the second operation first. Once again using the aluminum shredder roughing tool, 3 flutes, solid carbide, 5140 RPM, 40 inches per minute, 3 passes, going through 3/8 6061 aluminum. Now, don't stop the spindle, because the spindle takes a while to spin up, and then the software takes an even longer time to decide, oh yeah, spindle's fine. So ramping into this plunge cut to try to minimize the rat nest building up on the cutter, and it does not perfectly accomplish this. Once again, same parameters, 5140, 40 inches per minute, 3 passes. Go over and do a tool change, watching carefully because I've had some problems with the tool changer. Tool change accomplished successfully, 3/8, 3 flute, straight flute, Lakeshore carbide, aluminum cutting, zirconium nitride coated, making a nice 15 thousandths finish pass at 30 inches per minute. Back up, check the GoPro, check the blinking light. So many things to think about. Finger on the stop button just in case. Tool path, tool change accomplished successfully without breaking those pesky little plastic screws. Down into position with the 1/4 inch 3 flute Lakeshore carbide, 5140 RPM, 20 inches per minute. I slowed down the feed on this one a little bit because when the cutter hits some of these inside corners, I don't want to hit it quite as abruptly and aggressively, just being a little careful. Smaller the cutter gets, more nervous I get about cutter breakage. So there we have the optimized tool path, somewhat perfected. I've still got a little bit more rat nest on that cutter than I'd like, but I'm done optimizing. I'm done dicking with it. I'm just going to run parts. See you later. Back again. All of the first and second operation parts have been completed successfully, and they all look really nice. So that's kind of what they look like. Now, the challenge in the next step, I got to drill and counterbore 3 different things in this direction. Needs to have a counterbore, a clearance hole, and a tap hole, because there's going to be a slot. Get this guy into position here. There's going to be a slot cut to make a clamping ring that holds a magnet in place. So in order to correctly align the part, I made this little fixture, also made on the CNC, and the part fits into the fixture like that. In order to use this fixture, one thing I need to do is check to see that I have enough stick out on my drills, because there's going to be potentially a clearance problem with the ER20 collet holder and this edge of the ring, and I certainly don't want that to hit. So I had to check my stick outs very carefully. Just a word about stick out and tool length. In general, I tend to prefer the shortest stick out possible. I usually use the stubby drill bits, what they call the screw machine length drill bits, and put them as far into the collet as I can safely do. And this way I can automatically drill a hole, get it pretty much where I want it, without having to go through the extra step of doing a center drill or a spot drill. But it does mean that I need to kind of write on my setup sheet and remember, in some of these cases where I'm not just drilling into a perpendicular hole into a flat plate, where I actually have to be concerned about clearance, and I have to actually kind of like eyeballically verify that the stick out is going to be sufficient. So this is a slightly challenging little thing here. I've got my little fixture that just kind of like fits into the vise here against the soft jaw stop. Maybe, you know, if I was really ambitious, I'd make a custom soft jaw with this profile milled in, but that's not what I have today. So when the part fits in place, and of course I have to be really careful to make sure that there's no chips in there and that everything is nice and clean in between part changes, I actually set the Y0 to the back corner of the part, so I don't have to rely on the back thickness of the back of this little fixture. I don't have to rely on that, even though it was cut accurately, and I know it's accurate. It's just a good practice to get into when dealing with a part like this, to use the back surface of the part as the reference surface. And of course the Z reference is set on the surface of the vise, work offset 2, and everything seems to be in position. So get the old safety glasses on. The tool changer appears to be back to normal, behaving correctly. It's, as I said in the previous video, the automatic tool changer is a kind of a borderline design, and it requires a lot of fiddly little adjustments that are, in some cases, fairly difficult to make. And I thought I had it adjusted perfectly, and then it started misbehaving again. So I'm still going to be paying attention as I'm doing this, just to be sure. So let's take a look here. Single block mode. Verify pre-feed height. Gonna turn off the coolant, throw the old eyeball on it, and yeah, it looks reasonable. So go to the feed height, look again, and I am not absolutely confident about that. Doing a little more manually. This is a okay. I think it's correct. This is a kind of a tricky little part, and I certainly don't want to booger it up right now. Let me go back in the CAD room and just verify everything is correct. Actually, I'm not going to go back in the CAD room. I'm going to check it with the Heimer one more time. It kind of looks correct, but I'm not absolutely sure. And of course, this gives anybody who's interested can actually watch a little Heimer action here. Using the Tormach jog shuttle control, and it works, but it's not my favorite tool. Check to make sure that I'm on the 10th scale. Go over here and verify that, yeah, the 0 was pretty much where it needed to be. And I'm going to go in the CAD room and make one last and final check. Check, double check, check the check, check again. Yeah, it looks correct. Let's give it a go. This is the clearance drill for the 832. I'm going to go over here and, yes, in fact, it was correct. Looking good. Throw the old eyeball on it, finger on the stop button. All is well, no stick out problem at all. The next one, which is the 832 tap drill, goes all the way through the part. And this is the one where I need to be very careful about the stick out. Pre-feed correct. Feed looks good. Finger on the stop. And it clears just barely. Now, I'm not doing a machine tapping operation on this part because I can't stick the tap out far enough to clear everything, and it kind of doesn't matter because on this part, since I have the clearance hole followed by the tap drill hole, I can do like a perfect hand tap with the portable drill, getting it like perfectly aligned and centered because the tap follows the clearance hole. So I'm going to tap it by hand using the cordless drill. Gonna load up another part, run the run, come back for the fourth operation, which is a similar kind of thing with another specially designed feature and a different hole in a different place. And the fifth operation will be over on the Bridgeport with a slitting saw to cut the little slot. So for a small part, this guy has a lot of work in it. So see you later. So I'm back again and got another special little holding fixture because now it's necessary to drill a 1/4 inch hole perpendicular to this surface. So similar to the last hole, got my little fixture in place, and let me put on my safety glasses and make sure that everything looks good. No, that's not. Actually, it is. It's perfectly fine. Okay, so check, double check, check again, check the check. X0 is the same, it's the stop on the vise. Z0 is the same, it's the surface of the vise. Work offset 2, but need to put the Heimer back in. Verify over here that all is well, because this little fixture, even though most likely it was milled to the same dimension, I just want to be that one step extra little careful and set the 0 to the Y0 to the back edge of the part. So, well, the DRO shows me it was only 2/10 off, and the Tormach can't even hold 2/10. It's an open loop stepper motor machine with ball screws of who knows what quality, so I doubt this thing can actually hold 1/10. I think its spec is somewhere in the thousandths. So this will be tool number 31, which is a 1/4" drill bit where stick out is like totally no problem at all. Stubby drill. Wipe it before putting it in, because the power drawbar Tormach tooling system relies on a collet holding the tool holder in place, and it's got to be clean. You don't want any oil on that mating surface. So and I'm not going to have to do a tool change on this one, which is kind of nice. So single block, verify pre-feed, verify feed. Go over here and throw the all eyeball on it. Yeah, looks correct. 2,500 RPM, 10 inches per minute, fast peck cycle, 70 thousandths per peck, and that is a nice little hole in the right place. So that was the 4th operation. The 5th operation is going to be over on the Bridgeport, and it's going to be using the slotting saw. So grabbing an appropriate parallel here. Put the little fixture in place. The X alignment is totally like, who cares? So I don't really need a stop on the Bridgeport. So I go over here with the slotting saw, just touch off. Not going to be using the CNC part. The servos will be turned off. But I am using the DRO, so I consult my setup sheet, and observe that it's 0.36 from the top surface. And okay, 0.36, and it looks correct on the eyeball. I turn the slotting saw off before retracting because I don't want the saw to catch on what is now a loose top part. Don't want it to catch and yank the thing over sideways, so as soon as it breaks through, I turn off the spindle. So that is a somewhat complex little part. So after I run the full set, they go in the part polisher and the vibratory polisher, and I can knock another 10 off the number. And little bit by little bit, 750 parts. I think I've made 100 so far, so things are going well. I've had a couple of problems with the tool changer. Mostly things are going really well. Had a couple of problems with the cameras, but so far so good. Thanks for watching. It's been fun.